Hello student. Now this is the second class of the projectile motions. Okay. In the first class we have read something about projectile, that is introduction class, and now the second class. In second class we read the trajectory of the projectile motion. The equation of the trajectory. Equation of the trajectory means where this equation of this path. Equation of this path. How can you find the equation of this path of the projectile? Now by taking any point P and whose coordinate is x comma y. Okay, x and y are the two coordinates we take because this is x-axis and y-axis. And after t second later, particle reaches at the point P, x comma y. This is x and this is y, and we get x equals to u cos theta into t. This is the first equation, and y equals to u sin theta into t minus half g t square. That is the second equation. Okay, and we get, if we find the relations between x and y, that is the trajectory of the particle, and in mathematics it is called locus. So how can you find the relations between x and y, between the two coordinates of the projectile? By replacing the time. Here t equals to x by u cos theta. Okay, now putting the value of t here, y equals to u sin theta into x by u cos theta minus half g x by u cos theta square. Okay, now you get, this is y equals to x tan theta minus gx square by 2u square cos square theta. That is the equation of the parabola. Already we know it from first class. Okay, already we know in first class equation of the parabola of standard form ax square plus bx. Here y equal to x tan theta minus half gx square by u square cos square theta. Here a means g by minus g by 2u square cos square theta. Okay, and b means tan theta. B means tan theta. And easily you can find the angle of projections from this, because tan theta equals to B. So theta equals to tan inverse B. Okay, and you know this cos square theta easily substitute by tan square theta, because cos square theta is nothing but 1 by sec square theta, and sec square theta means 1 plus tan square theta. Okay, so if we write this cos square theta, as a equal to g minus g by 2u square into 1 plus tan square theta, and you know tan theta equals to b, so a equal to minus g by 2u square into 1 plus b square, and that is u. You get u equals to, or this is the a. If you know u, then you get a and b. That's the two coefficients of the projectile motions. Okay, y equals to ax square plus bx. Here unknown were a and b, and we get a and b. B easily we get tan theta equals to this, and this is. Now very interesting case here. We get another quadratic equations of tan square theta. Very interesting. Just we see here, y equals to x tan theta minus gx square by 2u square cos square theta. We can replace the cos square theta by sec square theta and sec square theta by 1 plus tan square theta. That is y equals to x tan theta minus gx square by 2u square into 1 plus tan square theta. That's the tan theta, tan square theta. We get the quadratic equation of the tan theta. That is y equals to 2u square y. Multiplying this to u square x tan theta minus gx square tan square theta. Now gx square tan square theta, okay, minus 2u square x tan theta and minus gx square plus 2u square y equal to 0. That is the equation of quadratic equation of tan theta. That is tan square theta. This is coefficient, just like x a. This is a, behave as a according to our quadratic equation. This is behave as b, and this is behave as c. So discriminant should be greater equals to 0. That is the condition. You can apply the J-1 and advanced problem. This is very interesting technique. Okay, you can apply in J-1 and advanced problem this technique. Tan square theta technique. That is b square minus 4ac greater equals to 0. Discriminant greater equals to 0. What is b? This is the b. Ax square plus bx plus c. So b is here. 4 into the power 4x square. That is b square. Minus 4ac minus 4a gx square. And c means that is 2u square y minus gx square greater equals to 0. This is the another quadratic equation you get here. Okay. This is the another quadratic equation. 4 into the power 4 x square x not equal to 0, so x square you can we get common x square here. So 4 into the power 4 minus 4 also common. So if we divide by 4x square, then u to the power 4 minus 4x square is we divided by 4x square. So g into 2u square y minus gx square greater equals to 0. So we get the maximum or minimum value of the y. Very interesting question. Generally asked in the JEE Main and medical and also in JEE Advanced. U to the power 4 plus gx square, g square x square minus 2u square gy greater equal to 0. Okay. Now this term 2u square gy less or equals to this a to the power 4 plus g square x square. So y less or equals to u to the power 4 plus g square x square by 2u square g. That is the maximum value of y. Y max. Y max. You get from this y max. Suppose a particle. Suppose application of this concept. If you throw a particle here, making an angle theta or alpha theta, then particle moves to the ground. Suppose this is height h. When the particle strikes here, this y will be max. This y will be max. What will be the value of u? You get from this equation this type of advanced problem or this type of JEE Main problem. You can solve from this concept y less or equals to this, that is y max. Suppose particle is thrown from a certain height, from a certain cliff or height with velocity u, and you have to find this u for y max. So you get this result. You get the value of the u from this result because we know it. You have to memorize it. Okay, ये पूरी तरह से दिमाग में उतार लेना चाहिए. Okay, you have to memorize this, because y maximum value, this kind of projectile you can solve. Okay, y max concept. Or now we find the expression of the range. We do not get the expression of the range in the previous class. So here range is nothing but ux into t. You know the time of flight and you know the ux. So you know the range u cos theta into 2u sin theta by g. Okay, some students can write this is ux, so 2ux uy by g. Some student can write this u square sin 2 theta by g. Okay, maybe written in this way. Sin 2 theta is maximum equal to 1. So R max u square by g. Yes, R max, maximum range. Okay. And sin 2 theta equals to 1. So theta equals to 45 degree. It's 45 degree. Or R equals to u square sin 2 into 90 minus theta by g. That is also equal. So theta and 90 minus theta. Theta and 90 minus theta for gives the same range R. So if you throw theta equal to 30, or if you throw with theta equals to 60, then you get the same range. You get the same range. So here theta and 90 minus theta and 90 minus theta. That means if it is alpha and beta, then alpha plus beta equals to 90. Then for alpha and for beta, if initial velocity is same, then range will be same of the projectile. And the general equation of range 2ux uy by g, or this, and range max this, and range max when theta equals to 45 degree, and range are equal when the projectile angles theta and 90 minus theta, that means alpha and beta, and alpha plus beta equals to 90 degree. Okay, student understand? Very interesting part of the projectile. And now find the relations. That is very interesting for H and R. How H and R are related. H and R. H means u square sin square theta by 2g. That is H. R means u square sin theta cos theta by g. That is u square sin square theta by 2g, and R means 2u square sin theta cos theta by g. So that is u square sin square theta by 2g, R by h. If you do this, R by h, so u square cancel, that is 2, 4. G cancel, sin theta cos theta by this, that is 4 cot theta. So another equation, okay, you get. This also you just memorized, okay. ये दिमाग में रहना चाहिए. Whenever it is necessary, you can apply in your problem. Okay. Now another type of projectile. We have another 3 type of projectile. This is always applicable in ground to ground. Okay, ground to ground. These all type of projectiles was ground to ground. All these type of projectiles were ground to ground. Now we read some extra concept. Extra concept means from a height. If you throw the projectile here, you can throw the stone in this way. You can throw the stone in this way. There's the 3 type of projectile. Okay. First, second, and third. And this is height. Okay. First, second, and third. First means this type of projectile. This is first. Okay. This is first. And the particle lands here. And here velocity Vx and Vy. Vx should be u. Vy we get the Vy and then we get the angle of landing. Okay, their alpha is very important for the question for JMN, because tan alpha equals to Vy by Vx. You get this alpha from the ratio of Vy by Vx, and Vy is nothing because here Uy is 0, Ux is U, so it is freely falling body. It is freely falling with respect to y direction, and that is h equals to half gt square. So time of flight root over 2h by v. Okay, then Vy equals to gt, and Vx is u, then tan alpha equals to Vy by Vx, that is gt by u, that is the alpha. Okay, the particle strike the ground with an angle alpha, and that is here alpha equals to gt by u. Okay, clear? Tan alpha equals to u by Vy by Vx, and Vy equals to gt. Okay, this is the first type of projectile. And time of flight, and this is range here. What is the range? R equals to horizontal velocity into time. R equals to horizontal velocity into time. So R equals to u into t. Okay, you can see the different type of problem in JMN with respect to this problem, like a staircase problem. You can solve in this way easily. Staircase problem. This is the staircase problem. Okay. If you just throw this stone, it will just, suppose if you throw this stone here and it lands in the 1, 2, 3, 4, fourth step. Every step height is h. Every step height is h, and the breadth of every staircase is b. Okay, that is the last breadth. So if you throw with u minimum, then it will land on the 1, 2, 3, 4, just grazing the surface of the fourth. And if u is maximum, then this is also the landing in the fourth. There is some different. Okay, whenever you minimum, landing will be grazing the surface. Whenever u is maximum, landing will be at the edge of the staircase, edge of the fourth step, 1, 2, 3, 4, at the edge of the fourth and grazing at the fourth. Okay, grazing. Whenever you minimum, it will be grazing, and whenever you maximum, at the edge. Clear? Now, it's just like this type of projectile. This is h, so it is 4h. So time of flight, freely falling body, because Uy equals to 0. So time of flight equals to root over 2 into 4h by g. And range b for u minimum. So 3b equals to u minimum into t, and 4b equals to u maximum into t. That's the concept. Okay, clear idea? Next type problem is with respect to trajectory. Next type problem, trajectory means y equal to x tan theta minus gx square by 2u square cos square theta. You can save this trajectory equation just like x tan theta common, 1 minus, this will be gx square by 2u square cos square theta into x tan theta, because we take it, okay, common. So x tan theta 1 minus x cancel, x by g divided r. This is the formula of r, because sin by cos, cos cancel, 2u square sin theta cos theta by g, x by r. So that is the another trajectory equations of the projectile. Y equals to x tan theta into 1 minus x by r. Okay, so this is the another type of projectile. Now the time is over, 20 minutes. Okay, so goodbye and good night. It is now 1 p.m. Okay, next video we will meet again.